सेंटर
आप
वाला
मुझे
है।
बताइएगा
मैम
जब
ये
रैप अप
आपका
करना है।
बाइलिंगुअल जाएगा?
हाँ, प्रेफरेबली इंग्लिश।
ओके फाइन मैम, मैं लास्ट के जब 5 मिनट बचेगा मैं आपको इंडिकेशन दे दूँगी।
ठीक है, ठीक है।
Ready, fire. Check.
नमस्कार, आप सभी का बहुत बहुत स्वागत है। आप देख रहे हैं पीएम eVidya चैनल नंबर 12 और एनसीईआरटी का ऑफिशियल यूट्यूब चैनल। आई एम रेणु भट्ट विद यू ऑल। और आप सभी के लिए हम इस सेशन में टॉपिक लेकर आए हैं मैथमेटिक्स का। ये 12th स्टैंडर्ड के स्टूडेंट्स के लिए हमारा टॉपिक है एप्लीकेशन ऑफ इंटीग्रल, दैट इज पार्ट 1। आज हम इस बारे में जानेंगे। और डियर लर्नर्स एंड व्यूवर्स, पिछले चैप्टर में मैम के साथ जो हमने चैप्टर किया था दैट वाज चैप्टर 7, इसमें इंटीग्रल्स के बारे में हमने बात की थी। और आज इस चैप्टर में हम बात करेंगे कि किस तरह से इंटीग्रल्स को यूज़ किया जाता है, उसका किस तरह से अप्लाई किया जाता है। आपको बताएंगे हमारे एक्सपर्ट जो हमारे साथ इस समय स्टूडियो में मौजूद हैं। उनसे मिलते हैं। चलिए, आप हैं मिस गुरप्रीत भटनागर, आप एकेडमिक एडवाइज़र हैं सीबीएसई में। मैम बहुत बहुत स्वागत है।
थैंक यू फॉर हैविंग मी।
और डियर लर्नर, ये जो लाइव सेशन है आपके लिए है, तो आपका पार्टिसिपेशन बहुत ज़रूरी हो जाता है। आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800 440 559। आप ईमेल भी कर सकते हैं हमारी ईमेल एड्रेस पे जो है dth.class12@ciet.nic.in। and in case you have joined us through our live streaming, that means you are on our NCERT official YouTube channel, go to the live chat box and drop your comment out there। हमारे एक्सपर्ट आपके सभी सवालों का जवाब देने के लिए तैयार है। उनको बहुत खुशी होगी आपके जवाब दे करके। और आप अपना साथ हमारे साथ बनाए रखें। कोई भी सवाल हो आपका इंटीग्रल से जुड़ा हुआ तो आप हम तक ज़रूर पहुंचाएं। तो मैम, लेट्स बिगिन दिस सेशन विद यू। और जैसे हमने बताया कि हमने पिछले चैप्टर में 7 में हमने इंटीग्रल्स सीखे थे आपसे, और हम आज इसमें एप्लीकेशन सीखने वाले हैं। तो और क्या क्या आप बच्चों को बताएंगे मैम?
मैम, आज हम सीखने वाले हैं कि इंटीग्रल्स को यूज़ क्यों किया जाता है, कहाँ कहाँ यूज़ किया जाता है। तो हमने क्लास चैप्टर 7 के अंदर, विच इज़ इन बुक 2 क्लास 12, उसके अंदर सीखा कि इंटीग्रल की टेक्निक्स क्या होती हैं, किस किस तरीके से इंटीग्रेशन की जा सकती है। फिर हमने डेफिनेट इंटीग्रल भी किया। डेफिनेट इंटीग्रल के हमने लास्ट क्लास में किया हाउ टू यूज़ प्रॉपर्टीज़ ऑफ इंटीग्रल। तो आज उसी की कंटिन्यूएशन में हम बात करेंगे, और हम बात करेंगे हाउ टू यूज़ इंटीग्रल कैलकुलस टू फाइंड एरिया अंडर अ कर्व। सो आप बोलेंगे भाई एरिया अंडर द कर्व क्या होता है, तो आज उस क्लास की इनिशिएशन हम करने वाले हैं।
Yes, ma'am. So shall we begin the session, ma'am?
Yes, yes, definitely. So, ma'am, I'd like to have your attention on this slide.
Right.
And as we both can see, there is a lampshade and it's switched on. So definitely there is a shadow of the light on the wall. So if I ask you how to find area of the light on the wall, now
that would be a sheer case of assumption, ma'am.
No, we'll bring integration into this. So here is another one. What if I give you a lampshade like this? You know, we have these kind of beautiful lampshades at home, and they have a beautiful figure-shaped shadow under them, above them. Now, in mathematics, I see so much of mathematics happening in these lampshades and their shadows. In this particular slide, you can see a parabola shadow which is falling downward. So, if I was to ask you what is the area of this shadow made by this parabolic form, so so using what we know from elementary geometry, we know how to find area of triangle, how to find area of circle. We know those basic calculations. Now this particular area cannot be found using those formulae that we know already. So just to bring one more relatable example, here is one of the F1 race course that we have on the Noida expressway. So this particular spectator's stand, which is a very beautiful elliptical paraboloid form. So see, mathematical people see mathematics in every shape around us. So
I can figure out.
So children who would figure out where is this parabola, it's right around you if you're just looking carefully. So we are going to find how to find the area between a curve, enclosed by a curve with another line. So this is going to be an interesting session. I'm sure our kids are going to appreciate it, and especially those who are appearing for their boards very, very soon. I'm sure this will help you to have a quick recap also. So with that, we shall start. Now, as I was mentioning earlier, that we can find the area of these figures, a rectangle, that will be length into breadth. Then for a circle, we have pi r square, only if the radius is known. Then triangle can be found using half into base into height, or Heron's formula that you learned in class 9. And I'm sure you can find for the parabola and for irregular figures, which are very, very rectilinear. So moving away from this, if I say that I want you to find the area, first of all, what's the concept of area? Now, area is the space enclosed by a closed figure. So the very first word we need to remember is that whenever it comes to area, it has to be a closed area. It cannot be open like we have done in linear programming. We have open region and closed region. So we cannot find area of open region. So for this particular chapter, the limitation is that we are going to find area between a closed curve from one point to another. All right. Now, if I ask you, how would you find the area entrapped between these two beautiful parabolas, this yellow portion? Now, this cannot be done using that elementary geometry. So there comes our big help, which is integral calculus. So what you learned in class, in chapter 7 is so useful and relatable to find area between the curves. Now, we are going to focus in class 12 syllabus only on simple curves. And when I say simple curves, we are going to focus on area below a line, below a circle, entrapped by a circle, between a parabola, ellipse, things that we are familiar in class 9, 10th and 11th. So this is what we are going to focus on today. So what do we need for that? We need to know how to use a concept of definite integral. That's chapter 7. So to start any maths class, ma'am, there has to be a recap. So a recap that we must have to know from class chapter 7. I don't know why I'm saying class again and again. We are doing class 7, chapter 8, application of integrals. Just for my...
Actually, that is class 12, chapter 8.
Yes. Okay. I think I'm getting butterflies. That's why I'm fumbling. So let's get into this recap. Now, the very first thing that we need to know is how to find area enclosed between a curve. Now, in chapter 7, again referring to the PPT that we have, if I give you just a part of a parabola as it's showing, and I've shaded the area in purple for you to find area of OABO, the whole closed curve, how do you think you're going to find that area? Now, in chapter 7, we had done a concept called limit of sums. So in that we drew tiny, very thin rectangular strips along the length down below the curve, as the animation is showing for you. I'm also giving you a reference of the section that in your book that you should refer to. So this is from 7.7.1, page 331. That is where we had done this. Now here, what do we know? Each of these strips are going to be of a length y. And if I say the width is dx, dx is a very minute width. Now, this is definitely a rectangle. If I'm asking you, what do you see that y dx, what kind of a form is that? Any child can tell us it's a rectangle. So if I ask you to find the area of this particular figure, it's length into breadth. That's simple as that, y dx. Now, this is basically area of one strip at an arbitrary position of the region. So there are infinite or numerous thick standing lines like this, or may I say vertical lines like this. Now here comes another question. I'm sure you can see there is gap in between those filled up area.
Right.
Now if I start putting these kind of strips, will it really give me the true area of the curve, below the curve with x-axis?
I don't think so.
No, definitely not. So in that case, what do we have to do? We have to start thinning up the strips. Basically, we have to make that dx, the width has to go as negligible, nearest to 0 as possible. So when we start filling with lots of thin strips vertically, I'm sure we'll be able to fill that area in a better way. So in that particular case, we will be able to find the area under the curve above the x-axis, which we refer to as area bounded by a curve with x-axis. Now here is another thing. We have to have the area from one point to another. Like you can see the origin of the parabola is from point O and it's ending at point A. So if I say with respect to x, to what points are you going? You are going from 0 to A, because that is where we have the interval. If I say A is a point, let's say 6, 0, any point on x-axis is x, 0. So if I say OA length is 6, what will be the coordinates of A? 6, 0. We already know what is the coordinates of origin, 0, 0. So if I ask you from what value of abscissa, abscissa refers to value of x. What value of abscissa are you starting from, at till what point on abscissa on the x-axis are you going? Definitely we are going from 0 to 6. So we have to take the starting to the ending from lower to upper. So that means I will not go from 6 to 0, I will go from 0 to 6. So the direction in which we are going to focus is going to be from lesser value to the greater value. I hope that's clear with all our kids. Now, what else do I need to know? We also need to know from chapter 7, the section 7.8.1, which is area function. As we are discussing at present, the integral actually helps us to find area below a curve, starting from a point to a point. So in this particular figure, we are able to see that the area that we have to focus. Now there are two blues, please just ignore that. If I ask you to find the area below the curve, that sweeping slide kind of a thing, from point A to B, this is where integrals comes from. So here this area function refers to that this x, the function of x, is denoted by ax, which we'll refer as area function. And in this area function, if somebody says, go ahead and find this area. Now, how do we do that? Now, this, according to section 7.8.1, as we already know, is using a concept of definite integral. So, look at the first thing that is catching your eye, the limits. The lower limit, we know what a lower limit refers to. The lower limit is coming from the starting point of the x-axis, from where the area is starting off. So that's why the lower limit is A, and the upper limit, that is the end point on the x-axis till what point you are going. So we are going to upper limit B. And inside the function, if we have fx dx and we go ahead and integrate it, this basically, this calculation is giving out a numerical value. Now what does that numerical value do? It gives you the area entrapped or enclosed below the curve above the x-axis from point A to B. It's as simple as that. I hope that's also clear, but you should open up your NCERT and refer to this. This is in chapter 7. There is another concept we must know from chapter 7. The first theorem of integral calculus. This is 7.8.2 from page 335. If you have the book, you can quickly open it by the side. Now, referring to the same figure, if I say, what is theorem? What is this theorem? The theorem says f has to be a continuous function. Now, what is the meaning of continuous? That curve goes on without any break or loops. So, if there is a function which is continuous and we want to find its area with respect to x-axis from point A to point B, then we are using the concept of area function. And to my understanding, or to put it in a very simple words, to find the area of this blue region, we have to see that the function has to be well defined and also it has to be continuous. Now, what does that mean? What if I tell you, for this reference, this is an example. We have done these kind of graphs in class 11. These are greatest integer functions. These are ladder functions also. They are broken functions. They are piecewise functions. So they are always around us. But if I ask you to find the area below this particular function, you can see this is not a continuous function. There is a break at -2, there is a break at -1, there is a break at 0, there is a break. So break means the ladder goes up. So for these kind of curves, we cannot find the area using the concept that we are going to learn today. But yes, of course, we can find for individual ladder, we can find the area and then adder, but that's going to be quite a laborious work to do. So we are going to focus on well-defined and continuous function. So these are all the things that we need to know from class chapter 7 of class 12th. Now let's begin the chapter itself. Before that, one more recap. This is something which we know as definite integral. Here, for a continuous function, how do we find the integral from a to b? This is how we do it. We find the integrand, and then after that we put the upper limit minus putting the lower limit in the integrand. For that, I would suggest you refer to the previous session we had, or you can also look through the book. There are many examples that you can have. Over here on the slide, I am also pointing to that capital F is basically the integrand being integrated. So whatever function you had, you first integrate it, then you put upper limit into it very carefully, and then subtraction sign, and then put the lower limit in your integration answer and solve it very, very carefully. Now what does that give us? It gives us area, as the previous slide was talking. Now with that, we can start today's session, which is all about how to find area under the curves using integral calculus. So this is part 1 for us, ma'am, today. So today we are just going to understand what to do, how to do, what not to do. So do's and don'ts class hai aaj, ma'am. So today is not going to be focused on solving question per se. I'm going to take very, very simple examples just so that we know the concept. And in the next class, in the next part, in the next session, we are going to practice solving questions using the part 1 session. So,
okay.
Yeah. So, here we go. In this slide, the heading says area enclosed by the curve with x-axis. Now, the bracket says using vertical strips. Now, what does that mean? Now, what we are going to do is, we are going to go under this curve, and we are also going along the x-axis. The area entrapped between the curve and the x-axis is the area we are planning to find, as we just discussed in the previous slide. Now, how do we do that? For that, we are going to draw vertical strips. For that, refer to integration limit by sum. So for that, I will not go into detail. That was one of the sessions that was taken earlier by us. So over here, if I just show one vertical strip, the length is y and the width is dx, and we put numerous thin, tiny vertical stripes like this along the y-axis. Along the y-axis means parallel to y-axis, or may I say perpendicular to x-axis. So vertical strips have been put. For examination point of view or for solution point of view, just one such strip should be shown. That is an indication that you are going to find the area under the curve with respect to x-axis. Now when I say with respect to x-axis and you are saying vertical strips, then remember the integral limits will be taken from x-axis. Now what does that mean? Look at the starting point from where the area is beginning, point A. And look at the ending point, that's point B. So my lower limit is going to be A, my upper limit is going to be B, and of course the function is fx. Now all that is to be thought like this. As I said, area function is the integration of the function of the curve under which we are trying to find the area, but the limits must be taken with respect to x-axis. And the best way you can remember where to take the limits from is sometimes because your curves might be intersecting y-axis also. So sometimes, you know, children get confused whether to take limits from x-axis or y-axis. Look at the variable in your integral. Now over here, everything is in terms of x. That means your limits shall be taken from x-axis. That's why you're seeing that the limits are from A to B. Now let's take a very, very simple example. I could have taken a parabola, I could have started with an ellipse or a circle, but let's start with something we already are very comfortable and familiar with. That's a linear equation, two variables. Children have been doing that since class 8th onward, graphically also. So if I ask you without using integration, no pressure on you, because we don't know how to use integrals, or we kind of getting to learn that. What if I ask you to find area below this line with respect to x-axis. Now let me show you the figure first of all. So here is my Cartesian, origin is right there. There I plotted my line. Very clearly the intercept on x-axis is going to be 2, 0, and on y-axis it's going to be 0, -2. Recall intercept form of equation, x upon a minus plus y upon b is equal to 1. But there are many other ways through which you could do the integration, plotting the line. So if I ask you how to find the area of triangle ACD, please look at the figure very carefully. Now I don't have to really complicate my answers over here. Even a child of class 8, 9, 10 can find area using half base into height. Now if that's how you're thinking, your base is AC. Now how much is AC? AC is 6 minus 2. What about the height? Clearly the height is looking like CD because it's looking like a right triangle. So how high is point D? We always refer to the point of Y. So what is that? 4 units. Now if I ask you to use the concept of half into base into height, as we already know that's such a popular formula, I'm sure all our students and viewers can see that's 1 by 2 into 4 into 4, or half on into AC into CD, and that's 8 square units. That's so simple, ma'am. Right. Now, because I want to begin the concept of application of integration, how about if I just remove all this and say, can integrals also help me to find the area? Yes, but there are some important things which must be there first of all. First of all, the function must be continuous and well defined. Continuous, well defined, yes, line is continuous and well defined. After that, you have to go from a lower limit to upper limit. Now, if I draw a vertical strip of height y, width dx, then we know using the area function that area of ACD can be found by taking lower limit as 2, you can see where that is coming from, and upper limit is coming from point C, that's right there. So we have lower limit 2 and upper limit 6. And inside we have the area of the arbitrary vertical length, which is y dx. Now I'm sure we can also find the substitute of y in terms of x, because the integral part has to be always in terms of x because we are taking our limits from x-axis. So I hope that's very clear. Lower limit, upper limit from x-axis, and value of y in terms of x from the curve that is given, or the function of the curve that is given. In this case, it's a line. Now once that is in place, we know how to do such questions. Y gets replaced. So instead of y, I have written x minus 2, and we know how to integrate that also. Integration of x is x square by 2, and integration of minus 2 is minus 2x. And recall that from the second fundamental theorem of calculus, when we have found the integration answer, we write the limits behind the function. So presentation is also very, very important. So you must learn how to present your answer. Now over here, we are going to just put the upper limit first. Again, second fundamental theorem of calculus. Put the upper limit into your integration answer, subtraction sign, put the lower integration sign, and just ahead solve it. Now be very careful, there's so much of calculation involved, and this is, ma'am, sometimes when the kids are very, very careless, or probably they're very, very overconfident, and they make mistakes after this step. So till this point, I'm sure you'll be cautious, but don't forget to be careful even in the computation of numbers. So in this case, the answer is 8 square units. Now answer using that half base into height and using the integration is same. You must be wondering, why would I use this method while I have half base into height? Now this was just an example of how to think integral calculus on a very, very basic question. We will take up advanced curves, we will take up parabolas, we will take up area between the curves, but that will be in the next session. For today's class, we are just learning how to think integration to use or to find area under the curve. That's what you must remember. Now moving on. I'm keeping the same line. Now, I have to get rid of this. What if I asked you to find this area, the tiny purple area? Now that area is made by triangle, the points O, B and A. We have all the vertices also, so how do we do that? See that the area is again below the curve, or is it above the curve? Since your line has gone down under x-axis, this time the area that we are focusing on is above the line, but it is below the x-axis. But the concept remains the same. So we are going to use a concept of vertical lines, like I've shown y dx, that yellow line is showing that that's the intention. We are going to solve this question using the x-axis. So in this case, area of OAB can be found using the limits from 0, which is my lower limit, till point A. What is the coordinate of x over there? The coordinate is 2. So we are picking up the distance of the line on x-axis. So origin to point A, that's 2. And of course, the line substitute is y is equal to x minus 2. As you can see, the graph's line is also written x minus y is equal to 2. So if you wanted to replace y, which you will have to, we have to find the function in terms of x. It will be x minus 2, and after that I'm super sure our kids can make sure of what is going on the slide. We integrate, and after that we put the upper limit, then a minus sign, then the lower limit, and carefully calculate it, and what happened?
Minus 2 square unit.
Yes. Now can the area be negative? Area is a positive quantity. Okay. Area cannot be negative. So did we do the question wrong? Not at all. Your concept is absolutely correct. Your answer is almost correct. We just need to tweak it a little, ma'am. Okay. Because we know this basically is the area function, which can at times give you a negative answer also. Do not panic. Just first suggestion is just go through your calculations once again. And if it is so that it's a negative answer, you can always make it positive by putting the modulus function of it. So we find the modulus value of minus 2, which is 2. So if your answer happens to be negative, first step, go through your calculations once again, whether you have taken the limits correctly, whether you have substituted the function correctly, and is your calculation correct or not. And if it happens to be negative, don't panic. Please just go ahead and make the positive answer of that, and that's what the area of OAB is. That's 2 square unit. Can you also notice that I'm writing square units in the final answer? In this whole chapter, please remember that your last answer has to be positive. It will be a numerical value, definitely cannot be 0. If it is a 0, it's a point of concern. How can area below a curve be 0? So either answer will be positive. If it is positive, we are happy. But if it is negative, as we are showing in this slide, please make sure to put a modulus sign to turn it positive. You don't have to write the statement. It's but so obvious. Place a modulus sign and just solve it, and then that's your answer. Now, what was the difference in previous slide and this slide? In the previous slide, we had the area above the x-axis, and in the next slide, we had the area below the x-axis. The area of above the x-axis was a positive answer, and the area below the x-axis gave us a negative answer. If you remember, that was 8 plus modulus of minus 2, which will be 2, and hence the answer is 10 square units. Now, in case you did not put the modulus sign, just think about that also. If you just took the area of the purple area as minus 2, and I asked you find the total area of the green plus purple, You would have done 8 minus 2 and answer is 6 square units. That's absolutely wrong. So please be very, very careful. There are some things which you must take care while you're finding your areas. Above the x-axis, with respect to x-axis, vertical stripes. And if your area is below the axis, but we are using the concept of vertical strips, you might be wondering what are vertical strips. There is another way to do the questions, but hold on, that's another slide altogether. So in this slide, what we are going to observe right now is that if you have the portion of the curve is, this is a wrong, text is wrong. I should have written the portion of the curve is above x-axis, then the area is positive, and if we are pointing to the, oh, this one I have written correctly, the portion of the curve is below the x-axis, then the area answer will be negative, and we know how to take care of that. So if I was to ask area of the total shaded region, then upper area plus modulus of the lower area. Do not forget that. This is when you are doing with respect to x-axis.
Right.
So I was referring to vertical stripes all this time. What if this time, if you look at this particular figure, the curve is making an area with respect to y-axis, and y is equal to c, that's my lower limit, and y is equal to d is my upper limit. And also interesting fact to know is that, note is that the function is in terms of y. So when we have in terms of y, our strip is not going to be horizontal, it's going to be, it's not going to be vertical, it is going to be horizontal. I'm sorry, I'm fumbling a little. So in this particular case, if you wanted to find the area of the blue portion, then we go just like previous. It's just that the horizontal strips are going to be area length into breadth x dy. That's what you are seeing inside. Instead of x, I have written fy, and the limits are coming from y-axis. That's what you have to remember. So when you are using horizontal strips, like in this case, your limits for the integral will be taken from y-axis. That's why you are seeing that the lower limit is c, and the upper limit, it's right there, it is d. And after that, you just integrate it, find the upper limit into that minus the lower limit, and concept is exactly the same. So we do find the area using vertical strips as well as horizontal strip. Let me quickly take an example just to clear this concept for you. Now, again, I'm referring to a very, very basic question which I'm sure my kids from junior classes can also take. Let us take a line again to the slide. Again, a very simple line, x minus y is equal to 0. I'm sure you can do that on your rough notebook right now. Just try to solve questions along with us. I ask you to plot this line. So this line is going to pass through the origin. And if I ask you to find this particular area, which I'm referring to OAB. Have a look at the coordinates also. This yellow area is made below the line with respect to y-axis. So it is bounded by the line as well as the y-axis. So this time, rather than taking the horizontal strips, we are going to take vertical strips. But before that, again, using the concept of half base into height, let's just know what the answer is. This is half into 6 into 6, 18 square units. So does the integrals also give us the same answer? That's a question we are going to fathom right now. So this time I have taken a horizontal strip, the green strip, which is length x, width y, dy. So what is the area of these arbitrary strips? Length into breadth x dy. And if I ask you to apply the area function, in this particular case, area of AOB is going to be x dy, as we know, and look at the limits from origin to point B, that's 6. So from 0 to 6. So the limits will be taken from y-axis, don't forget that. And of course, the variable x, that's the integrand part, that also must be converted in terms of y. So what will that give us? If I have x minus y is equal to 0, so x can be thought as y. So substituting x with y, what do I get? I get this. Now there is a mistake again. Instead of dx, there should have been a dy. Integrated, it's a y square by 2, upper limit substituted minus lower limit substituted, and if you calculate it, the answer comes out to be 18 square unit. Now in this particular case, I asked you to find area to the right side of y-axis. I hope you understand when I say right side of y-axis and left side of y-axis. Right now the right triangle that you are seeing, the yellow portion you are seeing, it is on the right side of y-axis. Now what if I ask you same line, but this time instead of asking on the right side, I ask you to find area on the left side, this green area. And I am also giving you the limits to what point you need to find area. So the area that I need to find is below the red line, and the shadow of that is going on y-axis from where to what? Would you say 0 to minus 8? No. That's another tip I am giving you. When you putting the limits, always go from lower limit to upper. That means minus 8 to 0. Don't go 0 to minus 8. In that case, your answer will be flipped. That means it will be opposite sign of what it should have been. But it works if you know the properties of integrals. So give it a thought. That could be your exploration hat that you could put on and maybe do it later. So for the time being, I am going to find the area using that half base into height, because I want you to see that whether you do half base into height or you use a horizontal strip like this yellow strip, which is again x dy. Why do I show that? Why do I need to show that? It helps me to show that I am going to take my limits with respect to y-axis. So quickly getting into that, the integral, the area of OAB in this OCD is going to be from minus 8 to 0 x dy, and replacing the limits, please see they are coming from y-axis, and the other one is also coming from y-axis, and I am going from minus 8 to 0. You could go 0 to minus 8 also, but think about it. What will be the difference if that was the case? So quickly jumping into the solution part, we know x has to be replaced in terms of y, and when I do that, I am getting this expression, integration of y is going to be y square by 2, putting the upper limit minus lower limit, and there you go. What happened again?
It's in minus?
Yes. So when I went below the x-axis, the area was negative, and when you go to the left hand side of y-axis, I get a negative answer. Area can't be negative. So what do? I place modulus, and hence my area is not minus 32, it is actually 32 square units. All right. From this slide, what do we know? We know that the yellow area is on the right hand side and the purple area is on the left hand side of y-axis. In this case, the question that I solved, the right hand side area was positive, whereas the left hand side area was negative, which we ensured to make positive by putting a modular symbol, and hence my final answer is 50 square units. So I hope you remember you are supposed to turn the negative answer of integral into positive to find the total area. So what is the summary for this? The observation that we have made here is, if we are finding the area on the left hand side of y-axis and the limits are taken from y-axis, area will be negative, and if we are finding area on the right hand side of y-axis, the area will always be positive. But in case you want to find area of both, then don't forget to put a modulus on the area you found on the left side of x-axis. So this is what we have done. The observation as, okay, I think we can skip this slide. We are just a repeat. And this is what we have learned today. What we learned today is that how to find area enclosed by a curve with x-axis using vertical strips, and how to find area enclosed by a curve with y-axis using horizontal strips, and also how to find area by a curve on either side of the x-axis. So if you understand the concepts that we have discussed today in session 1, part 1, I'm sure you will be curious to open your books and see if you can try a question or two. Please do that. But before that, go through the content of NCERT, read through it, and try to make sense of it. If you have any question, write to your teacher, speak to your teacher or your guide to clear your doubts. Because unless your concepts are clear, unless you know how to apply a concept correctly, you will not be able to get your answers to the questions you're trying, and that can be frustrating and that can put doubts also. So build your concepts, build the correct competency before you actually start practicing questions. So this was our session 1, ma'am, where we have learned the techniques or how to apply integrals to find area.
And we have just come to know do's and don'ts of integral. Ma'am, we still have so many time with us. So can you please tell our learners about the key points they have to remember?
Okay. Now the first key point is that the function under which we are trying to find the area has to be well defined and continuous. After that, we can only find area of a closed curve. So closed curve ke liye we need to have the vertical strips which can define the area with respect to x-axis. Now the do's and don'ts of this is when you are finding with respect to x-axis, your vertical strips will be used. And what is vertical strip? The height. Now what is the height? Height is always y part. And when I say the width part or the length along x-axis, that is always referring to dx. dx is the minutest thickness strip that we can have, as thin as almost 0, so that we can fill that whole area under the curve. Now when I find y dx and I have to choose my limits, please remember you have to choose your limits from x-axis. Whenever you are doing y dx, vertical strips, the limits have to be taken from x-axis, and that also must be taken from lower limit to upper limit. Because if you will take from upper limit towards lower limit, for example, if I find the integral of from 2 to 5 versus we take from 5 to 2, they both give different answers. And how? Why don't you try a question on that? That is how you should do. So closed interval a to b, when I say a to b, a has to be less than b. A cannot be equal to b either. Just think about that. Why is that also? So a lot of things that you should also question on your own. Why should upper limit and lower limit be different from each other? For this particular chapter, why should we go from lower limit lesser than the upper limit in case we are going on x-axis? Again, the area could be above the x-axis, below the x-axis, as we discussed. Above the x-axis, if you are finding the area will always be positive. Now here this positive number could be any real number that you know of. It could be a root answer like root 3 by 2. It could be a fraction answer 9 by 4. It's all right. Do you need to convert it into decimal? Not really. But do not forget to write the unit of the area. What is that? Square units. Do I write square centimeter? No. Because the graphs are of various units, so we don't always restrict ourselves to centimeter unit. So we will write very open-ended square unit. But if you find the area below the x-axis using the vertical strips, which is again y dx, so your lower limit to upper limit, lesser limit to higher limit. And in this case, because your area is below the x-axis using vertical strips, it is bound to give you negative answer. Then what do? Area has to be positive. So how do I make it positive? So let's say your answer came out to be -9. First step, please go through your calculations again. Go through the graph again. Did you take the limits correctly? Did you write your integrand correctly or the substitute integrand correctly? Did you integrate correctly? So at every step you should check, because in these kind of questions anybody can make a mistake and it can be overseen. But in case you get a negative answer and it happens to be the area below the x-axis, it is bound to be negative. And in that case, because area should be positive, we always put a modular symbol and hence the area has to be positive. But when we went on the y-axis, we were using what kind of strips? We were using horizontal strips. Horizontal strips will be width x along the x-axis, and the thickness of the width strip is going to be dy. So area of each rectangle like that of width, the height x and the width of dy will be x dy. But this time you take the limits from y-axis. But here again two cases. So along the y-axis we can have on the right, some of the area is on the right side of y-axis, some of the area is on the left side of x-axis. If the area is on the right side of y-axis, your answer will always be positive. If it is turning out to be negative, that means you have definitely made a mistake somewhere. So you need to rework through your answer, go through your calculations, go through the substitutions, etc. very, very carefully. But if your figure's shading is on the left hand side of the y-axis, then in that case your answer cannot be positive. It can be if you went from higher limit to lower. But my advice would be, if you are on the left hand side of y-axis and you're finding area of the figure using the y-axis, then please go from lower limit to upper limit, and in such a case your area will turn out to be negative and we know how to make it positive. So please remember all these things while you're solving your questions. Along with that, you must also revise some of the graphs that you were taught in class 10th and 11th. Because in this chapter, you will be dealing with graphs of parabola, ellipse, circle. In such case, you must know what is the equation of a circle with center origin. The standard form is x square plus y square is equal to radius square. But sometimes the equation of the circle may be in its general form. Recall class 11. So you need to revise concepts from straight lines and conic section of class 11 to be very good with this chapter in class 12. For a parabola, we have parabolas of y square is equal to 4ax, x square is equal to 4ay, y square is equal to minus 4ay, etc. So you must know, and we are going to do simple curves with standard form. So for parabolas, we are going to have the vertex at origin. So we are not going to have questions where the vertex is shifted. We do have one example in NCERT, but that's only as a HOTS question. So test your limits, and you should also know how to shade along inequalities, that is linear inequalities in class 11. If you know that, then you will be able to shade equation of a circle which is not inequality but inequality. And what am I talking about? S square plus y square less than equal to 9. Now it looks like a circle with center origin, radius 3, but because there is an inequality involved in it, you are supposed to shade. Now do I shade inside the circle? Do I shade outside the circle? For that, shading concept must also be very, very known to you. We will start the next session with that, how to do linear inequality, how to shade on either side of a curve, how to decide that, and then how to find area using the integrals, but that will be session 2. So from my side, this is it for today.
Thank you so very much, ma'am, for your detailed information of application of integral part 1. Thank you so very much, ma'am.
Thank you so much. Thank you so much for having me.
So dear learner, we have just learned about the application of integral part 1. In this session, we have learned do's and don'ts of integrals, and in next session, our next session would be on how we can use that integrals, right, in our equations and problems. So dear learner, it's time for me to wrap up this session, पर हम अपनी expert गुरप्रीत मैम एक बार फिर से आपको बहुत बहुत धन्यवाद करते हैं.
Thank you, ma'am.
इतनी बेहतरीन जानकारी के लिए. डियर लर्नर्स, आप जुड़े रहिए, बने रहिए PM eVidya चैनल पर और NCERT ऑफिशियल यूट्यूब चैनल पर मुझे फिलहाल रेणु भट्ट को दीजिए इजाज़त। हम कुछ ही देर में वापस लौटेंगे अपने एक और लाइव और स्पेशल फ़ोन इन प्रोग्राम के साथ। नमस्कार।